Bismillahirrahmanirrahim and Assalamualaikum warahmatullahi wabarakatuh and very good morning to everybody. So for today, we will continue our discussions about chapter 8 regarding alkyl halides and also elimination reactions, which is quite important about this one. So we already cover half of the chapter, so we will continue to discuss about the remaining chapters. So before that, I already mentioned and stated that we will have a class, replacement class for 3 days. So I hope you agree with the date. But during that time, from 22 until 28, I will not in Penang, so I will mobile. So it's depend on my internet connections. And we will do during the night. So we will do, during the night. Because if I'm not mistaken, on 17 January, we will have a test. And after that, we have to prepare for the final. So, and also I just want to let you know on, if I'm not mistaken, on 28 on December, okay, we will have quiz. Maybe we will do online during the night. So I will open the slot for 2 hours, but once you start the process of answering the questions, you will have 25 minutes, and it's cover chapter 7 to 8 for 15 questions. So it's just MCQ. The question is not really difficult because it covers CLO1. So it just tests you about the basic understanding about chapter 7 to 8. Okay, so we will continue now. So as I said, we already have this kind of chapters. So we do proceed with chapter 31. So okay, for this one, the lecture outline, so we already go to introductions. What is the elimination reactions? Normally, it's you have to remove the alkyl halides and also the extract the first proton, and after that form a new form, which is a pi bond, okay, as a double bond. So there is we already discussed about the mechanism of eliminations, what is E2 mechanisms and ZZ rules. So now we are going to the E1 mechanism. We just allow some student be going in. So okay, let's go to the 31 slide 31st. Okay. Okay, for E1 mechanisms, the hydrations, the hydrohalogenations, okay. The hydrohalogenations, okay. Hydrohalogenation, it means you remove hydrogens and halogens. Okay, so this one. Remove hydrogen and X. Okay, so of CH3Cl with water to form a double bond, okay, can be used to illustrate the second general mechanism, which is E1 mechanism. Anybody who have highlighted, you can do this, okay. So E1 reaction exhibit, which is the first order kinetic order, okay, which is depend on the concentration of alkyl halide. Okay. So the E1 reaction proceed with two step, similar like SN1 reactions. Okay, so the bond to the leaving group break first. Okay, first. Okay, this is the first process. Okay, break the leaving groups is mean halogen groups. Okay, so first before the this one, the second process, which is the pi bond is formed. The slow step is a unimolecular, so it's involved only the alkyl halides. Okay, if we ask about the what happened to the rate of reactions if we change the concentrations of alkyl halides, so it will reflect the rate of the kinetic of reaction, which is fast or slow. So the mechanism of E1 first, similar like E1, so it will remove, this is the first one, heterolysis of Ci bonds, okay, or C halogen bonds, and after that, form a carbocation first, okay, and after the form, okay, remove. This is the first one, okay, heterolysis and carbocation formations. So, and after that, base, okay, a base, okay, remove the proton from the carbon adjacent to the carbocation, and the electron pair of the CH bond form a pi bond. So this is a base, and this is classified as a base. Okay, we'll extract the proton, only the proton, so a pair of electron here will move to the carbocation and form in this alkene. Okay, this is alkene. Okay, and in iterations, okay, meanwhile in iterations, the leaving group come off as a beta proton is removed and the reaction occur in one step. This is very fast step, fast reaction. Okay, in iterations. And however, in this reaction that we discussed today, okay, the leaving group come out first, okay, before the beta proton is removed, okay, and the reaction occur in two steps. If we discuss by energy diagrams, you will have two loop, okay, two loop formations of intermediate, which is very reactive, okay, is a carbocation intermediate. So, okay, if we talk about the energy diagram, this is the energy diagram which is represent the E1 reactions. Bear in mind that you should have the axis, which is this one is the y-axis and this one is the x-axis. So, if we ask about this one, so make sure you draw the axis first, and at least you can get 1 marks. Okay, so the second one, you have to draw the starting material, which is one is starting material. This is a product. Okay, you will get another 1 marks. Okay, for example, the transition state, these two transition state, and the intermediate, you will get another 1 marks. And activation energies, okay, both activation energies, and after that delta H for the both, and also delta H overall, so you will have another 1 marks. And then lastly, the shape of the diagrams will reflect the another 1 marks. So I think total this one will be 6 or 7 marks for this one. So if you get the question regarding this energy diagram, don't leave it as just ask it, just answer it. So hopefully you will get more mark for that. Okay, so next. So the effect of alkyl halide structure in E1 reactions, okay, the rate of E1 reactions increase by increasing of the R groups on the carbon with the leaving group increase. So this is the primary, this is the secondary, and this one is tertiary. they will increase E1 reactions, okay, and also the stability of carbocation is increased, similar like SF1. So if we ask why, so you have the answer. So it's always preferred for the tertiary alkyl halides for the E1 reactions. So you will see the difference here. So for the substitution reaction, is always depend on the nucleophile. Meanwhile, for the elimination reactions, it almost depend on the base. Okay, the substitutions is the substitution of nucleophile. Meanwhile, for the eliminations, you have to attack first the the proton, because base will interact with acid. So the effect of base of E1 reactions, the strength of base usually determine whether it's follow E1 or E2 reactions. For the elimination, they have only two. The first one is E1 or E2. So you have to determine this one. So what's next? So the strong base, okay, the strong base. Here we have the strong base. Anybody who have highlighter, you can highlight it. The strong base like this. These favor E2 reactions, okay, and the weaker base like water and also alcohol favor E1 reactions, okay, and for the radioselectivity of E1 reactions, the ZZ rules apply for E1 reaction also. So for the ZZ rule is also apply for the both E1 and E2 reactions. So E1 reactions is radioselective. You have to understand what is the meaning of radioselective, and favoring formation out of more substitutions. This is the keywords. The more substitutions and more stable alkenes. So for example, if we have one bromo, one methyl-cyclopropanes, so they have already have two beta eliminations here. The first one in these positions, okay. So because they are in the similar orientations or arrangements, that you have both beta 1 positions and only one beta 2 positions. Okay, if we draw proton here, so you will have another one. This one, for if you draw clearly, you can see this is the hydrogens. So the more substituted alkene, will be a major one. In this case, a tri-substituted alkene will be a major product. Meanwhile, for the di-substituted alkene will be a minor product. So don't forget to put plus. So you will have a mixture. This is the product of E1. It's they have more substitutions and form a more stable alkene. It's mean more substituted will be a major compounds. Meanwhile, the less substituted will be a minor products. As a summary, for the kinetics, this is the first order. It means it depends on the concentrations of alkyl halide. So you can put as a conclusion rate. Halides. So they have two-step reactions. It means they have two loops, two transition states, two activation energy, two delta H, one delta H overall, one intermediates, and the identity of R, the more substituted alkyl halide reacts faster. It means tertiary alkyl halide is favorable. Base is favor weaker bases, such as water and also ROH, alcohol. For the living group, a better living group maturation faster because the bond of living group partially broken in predetermined state. This means for fluorine to iodine, the rate will be increased. For the solvent, is depend on the is depend on the polar protein solvent. Okay, if you have polar protein solvent, just list down what is polar protein solvent. Okay, because E1 reaction occur with the competing with SN1 reactions. E1 reaction of the alkyl halide are much less useful than E2 reactions. Okay, because to make it simple, so E1 reaction is competing SN1 reactions. Okay, so that E1 reaction less useful compared to E2 reactions. Okay, so okay, SN1, because of the statement of previous statement, so SN1 and E2 reactions, okay, have exactly the first rate determinant step for the formation of carbocation. So if we see it and we compare with SN1 reactions, E1 reaction have the first step, which is the formation of carbocation. So the differ is what happened to the carbocation. So siapa lagi mau masuk ni? So in SN1 reaction, the nucleophile attack at the carbocation. The difference is between SN1 and SN2. So this one is SN1. Okay, SN1. The nucleophile attack the carbocation. Okay, attack. Okay, attack the carbocation. Okay, anybody will have highlighter. Okay, SN1 nucleophile attack. And form the substitution products. Meanwhile, okay, for the E1 reactions, okay, E1 reactions, okay, the base will extract the protons, okay, which is here, okay, and form a new pi bond. Okay, SN1, substitutions, eliminations, new pi bond. This is the difference. Okay, so for the stereochemistry of E2 reaction, the transition state at E2 reactions consists 4 atoms from alkyl halides, 1 hydrogens, 2 carbon atom, and the group leaving group all aligned in the planes. So the H and X, there are 2 ways. Okay, there are 2 ways. Maybe we have highlight here. So masuk lagi ni. So there are 2 ways for CH and CX bond to be a coplanar. So in this case, the HX atom can be oriented at the same side, okay, which is a syncplanar, which is the syncplanar at the same side, okay, same side, which is this one, the same side, or they are at the opposite side, which is a anti-periplanar. Okay, opposite. Okay, okay, which is anti-periplanar. Okay, first is syn, second one is anti. So there are 2 possible geometries in E2 reactions, mostly happen in anti-periplanar geometry. Okay. I will prepare some questions to explain about anti-periplanar. Usually it's the best explanation is in cyclic systems, okay, cyclohexane for example. So this arrangement allow the molecule react in the lower energies, okay, lower energies and staggered conformations. I think you already covered the staggered conformations, right, in Newman projections, chapter 4, and allow to incoming base and leaving group to be further away to each other. So it's mean the removings of the protons, okay, before we remove the alkyl the halide groups from the alkyl halides. This should be further away and make the process is easy. So in this case, okay, base, okay, we just take this an examples here. So for example, like this, okay, if we see clearly at the back, at the fronts will be like this. Okay, each meanwhile at the back, this is X halogen groups, this one. So the base will extract the proton here, okay, giving a pair of electrons to this one and make this one move easily. Okay, so it's easy to have this anti-paraplanar geometry. In this case, can be explained in Newman projections, which is this one is the anti positions. Okay, so this is anti-paraplanar and staggered. Okay, the electron-rich groups far apart. Okay, make the process easier compared to the syn paraplanar. Okay. So for the anti-paraplanar geometry in cyclic systems, okay, 6-member ring, for example, like this. So we have 6-member ring. Usually it's referred as a cyclic scene, like this. Okay. So okay, they have two chair conformations. Okay, and so the conformation A, for example, here prefers scenes in the bulky groups at the equatorial positions. Okay, they have here. This is more stable because this bulky group, which is chlorine, in the equatorial positions. Meanwhile, this one is less stable because this one is a axial position. So we are preferred to these positions. Okay, if we draw. Okay, continue from this explanation. So they have trans-diaxial geometry for E2 reaction. So for E2 eliminations, anybody who have a lighter, you can highlight here. The Cl bond must be anti-paraplanar to the CH bond on the beta positions. Okay, and this occur only when the proton and chlorine are both in the axial position. So in chapter 4, we already covered about the axial and equatorial positions. So if we as its anti-positions, so you have to understand this ones. Okay, the requirement should be the both alkyl and also alkyl halides and also proton should be trans-diaxials. Okay, it's mean proton and also chlorine or halogen group should be in axial positions. So as I said, based on the previous slides, this is the favorable arrangements. So we have this one because they have axial position. This is the axials, and they have two possible axials. The first one is this one. Second one in this one. So you will have two products technically. So, but because there are no substitutions here, so they have possibility to extract from here and from here. So, okay, make sure they have anti-paraplanar to explain this situation. So anti-paraplanar, it's mean trans-diaxials. So you should have this kind of positions. Okay. So for E2 reaction of cis and trans isomer, consider E2 the hydrohalogenations of the cis and trans. 1-chloro-2 methylcyclohexanes. You will have two products here. One is in the cis, another one is the trans conformations. So the cis isomer exists as two conformations, A and B, which is one as a group axial, another one equatorial. Okay, so as I said, you should have the alkyl group, the halogen group in the axial positions. So this one is favorable compared to this one because the chlorine, in this case, chlorine in equatorials, because they have should be trans diaxles. Okay, diaxles. Okay, so they will extract this base and also removing this chlorine. Okay, so this is the cis positions. Okay, so for the radiochemistry of E2 reaction of cyclohexane, because conformation B has two different acyl beta halogen groups, okay, it's mean if we draw clearly, when you get this kind of questions, what you can do is you draw nicely the compounds. Okay, so you will have this Cl, draw all the substitutions here. So this one is H and this one is H also. Sorry for my handwriting. So this one is CH3 and this one is H. So we'll see all the figure pictures about the elimination reaction. So in this case, you will have two, okay, two substitutions here. Okay, so they have HA. If you remove HA, okay, this one, which is this one, so you will get di-substituted alkenes. Okay, di, this one. Okay, we call di substitutions. Okay, let me draw clearly the projects here. Okay, if you remove HB here, okay, you will have tri-substituted alkene. So because they have three substitutions here, right? Okay, so and in the end you have to determine which one is the major compound and which one is the minor compound, and this one is the major compound because they have more substitutions compared to another one. Okay, and for this one, these two explained by ZZ rules. Okay, so there are more stables, more substitutions. So if you follow this rule, you will find tri-substituted alkene will be a more stable alkene. So acyl leaving group in E2 reactions. Okay, for the trans isomer, okay, you will see S2 conformer C having a two equatorial substitutions. Okay, chlorine should be in the acyls. So this is the favorable arrangement. So if we see clearly, D is two acyl substitutions. And after that, if we draw clearly H and H here, you will see only D, okay, have favorable arrangement. So because D conformer has only one beta hydride eliminations, if we draw again the chair conformations about these compounds, you will find only one substitutions, one hydrogen in beta acyls position, so it's only produce only one products, okay, which is di-substituted alkene. Okay, if we try to ask you why this cis will produce two and this trans will produce ones, and so you have the answer for this, because the positions of diaxles will for trans only have one, and for cis they have only two positions and two possibility to remove the base. So, and this is why the cis have a mixture, meanwhile for the trans have only one product. Okay, so for the comparison for E1 and E2 mechanism, okay, is depend on the strength of the base. So you have understand and memorize this one. For the E2 mechanism, they are more common and useful, and favor with strong negatively charged, especially OH and also methoxide ions. Its reaction occur, reactivities is reactive with methyl and no, not methyl. The primary, secondary, or tertiary, okay, is favorable to the primary. For the E1 reactions, okay, much less useful. Wow, ada baru masuk lagi. Okay, for much less useful reactions, a mixture of SN1s or E1 reactions usually result. It's favor weaker neutral base, for example, water and also alcohol. And this mechanism does not occur with primary, and because the stability of carbocations similar like SN1, and it's favorable with tertiary alkyl halides. Okay, you can add more information. It's favorable with tertiary alkyl, don't worry. So E1 elimination and alkyne synthesis, a single elimination produce one sigma, one pi bonds, okay, one pi bonds, and two consecutive elimination reaction produce two pi bond of alkyne. So its alkyne is mean triple bond. Okay, so for example, this alkene is one sigma bond, okay, which is we cover further in chapter 10. Okay, this is alkyne with two more the pi bond, which is triple bond. So two elimination reactions are needed to remove 2 moles of HX from the dihalide substitution substrates. For examples, we have this kind of compound. So the base, this is the base. We'll extract the proton. Okay, this pi bond will this sigma bond will give to this sigma bond and form a new pi bond, and automatically just kick off the halide groups. We give the vinyl halides, and if we further do some eliminations for the geminals dihalides, okay, and you will have a vinyl halides, and the further elimination reactions with the base will be a triple bond. So this is the mechanism how it's went. So we will discuss. I will prepare some questions about this one, and we will discuss further about this one. Okay. So okay, whether it's a geminal or vicinal dihalides. Okay, vicinal or geminals. Yeah, you will know vicinal is a different carbon for the alkyl halides. Okay, for the geminal, if you have two alkyl halogen group at the same carbon, this is the definition of vicinal and also geminal. Okay. So for basis of alkyne synthesis, a strong base. Okay, anybody who have highlighter, you can highlight her. The strong base are needed to synthesize alkyne by the hydrohalogenations, then needed of synthesize alkene. So this one for alkyne, so we will discuss in chapter 11. Don't worry, we will repeat again in chapter 11. So the typical base that we use is amide. Okay, as a sodium amide. If you see these reagents, or I know this is the elimination reactions and usually used in alkyne synthesis. Okay, potassium third butoxide is a bulky base. Bulky. I love this base. Okay, can also if you use bulky base and use the MSO, so you will see this kind of alkyne synthesis also. Okay, this is the first reagents that we use. Sometimes we use this one as the second reagent. So stronger base are needed to break the stronger sp2 hybridized CH bond with the second elimination. Okay, we don't ask too much about this one. So the hydrohalogenations of dihalides. Okay, for example, this is the geminals, and this is the vicinals. Siapa ada pensel, tulis kat sini. Ini apa benda, ini apa benda. Okay, so make sure if you see two equivalents, it will give a alkyne. If I state only one equivalence, it's only alkene. Okay, or we are using the words excess. Okay, normally we will discuss more about this one. Okay, So when is the relation SN1? This is very important. When the relation is SN1, okay, SN1, SN2, E1, E2, good nucleophile that are weak base favor substitution over eliminations. Good nucleophile, weak base favor substitutions. Okay. So in this include iodine. Okay, this is the list of the nucleophile. So usually they are favor to the substitutions. Okay. So bulky non-nucleophile, nucleophilic base favor elimination. So bulky non-nucleophilic base favor eliminations. Ada yang baru masuk lagi. Over substitutions. So for examples, okay. Just remember this base. Okay, you will have this bulky base, DBU and DBN. Okay, there are two sterically hindrance to attack tetravalent carbons. They are too bulky. Okay, the size is quite big. They are almost impossible to do substitution. If you see this kind of base, so you said, oh, this is eliminations. Okay. However, they are able to remove a small proton, favoring eliminations over. They are favoring eliminations. So by the highlighter, you can highlight here. Over substitutions. For example, this is a strong nucleophilic base for this one, potassium terbutaoxides. They are favored to extract proton only, not doing the substitutions to give the elimination reactions. Okay. So for how to predict the reaction mechanism, whether there was a SN1, SN2, E1, E2. So for tertiary alkyl halide with a strong base, elimination occur by E2 mechanism. Okay, strong base, elimination occur. Okay, so this is a strong base. Okay, tertiary alkyl halide will give you E2 products. Okay, with weak base, tertiary alkyl halides, okay, weak base like water here, they will give you a mixture SN1 and E1 product. Okay, you don't have you have to memorize that one. Okay, doesn't have any shortcut for this one. Okay, maybe you can make a table for that. Okay, so for primary alkyl halides, strong nucleophile. Highlighter here, strong nucleophile. Substitution occur as SN2 mechanisms. Okay, strong nucleophile like hydroxide here, hydroxide ions. There's a SN2 products with a strong base, bulky base, and elimination will occur. Okay, this is strong nucleophile, this is strong base and bulky base. If you see this potassium terbutaoxide, directly it will E2 products. Okay, don't think too much. Okay, bulky E2 product. The secondary alkyl halide is quite tricky, so you have to give more attention for this. So with a strong base and nucleophile, a mixture of SN1 and SN2 and E2 products as a result. So this is the secondary alkyl halides, and the strong base and nucleophile. So SN2 product and E1, E2 products with the strong base, bulky base, strong base, bulky base like potassium terbutaoxide. Elimination occur only E2 mechanisms. Okay, and with the weak base nucleophile or bases, a mixture of SN1 and E1 products as a result. So everything is depend on the base and nucleophile and also alkyl halides. So it will determine the direction of the reactions, whether they are SN1, SN2, E1 or E2 reactions. As a conclusion, they already make you a tables. So for the primary alkyl halide with the strong nucleophile, maybe you can make some additional notes. What is strong nucleophile, for examples? Okay, So it's favorable only SN2 reactions. Okay, for the with the strong bulky base, if we said bulky base, what is that? Can naming, okay? Potassium third oxide, DBU, for example, like that. It's only favorable for E2 reactions. The very tricky one is the secondary alkyl halides. So how you can determine the secondary alkyl halides direction of reactions? Okay, you can do and check the base and also the nucleophile. Whether if they have strong base and nucleophile, they will go both SN2 and E2 reactions. Okay. For the strong bulky, if you see the strong and bulky base, for examples, it's only direct you only one E2 reactions. Okay. And lastly, weak base and nucleophile is a mixture reactions, which is SN1 and E1 reactions. Okay. And for the tertiary alkyl halides, if you see weak base and nucleophile, it's SN1 and E1 reactions. And for tertiary alkyl halide with the strong base, if you see the strong base, it's favorable E2. Strong base, usually what we can see is the base that we use for that one, because they are not favorable for SN2 reaction. So this one, for the bulky base, if you see the bulky base, similar potassium third oxide. Okay, there's the only bulky base that we have, the common one. Sometimes we use DBU. So if we write DBU, you will know what is that. Okay. That's all for chapter 8. We already finished chapter 8. So I hope as a conclusion that we can see here is the most important thing, you know how to predict as what is SN1, SN2, E1, E2. If we is depend on the type of alkyl halide, the first one, and also depend on the nucleophile and or base. If we see clearly the substitution and also eliminations, they are doing substitutions. For the elimination, they extract the, for the elimination, they will extract the acidic protons. Okay. For the elimination also, we discuss about the anti-periplanar positions. Usually is depend on the cyclic system like cyclohexanes. Cis will give you more product compared to the trans, because in general, we discuss in general, because I will give you some question. I think in tutorial, in assignment, in discuss questions, practice questions, I give you one questions about this, so you can answer that one. Okay. You are free to ask me about this one. Maybe during the class, you can come in front and ask me about this kind of questions if you need more explanations, and I'm happy to do that. So